word in chemistry that you may not have heard before, and that word is the word mole. In chemistry, a mole is a word that we use to describe a enormous, huge, gigantic number. It's like saying to you, if you went to the store, can you get me a dozen eggs? If I said to you a dozen eggs, you would automatically think in your head, oh, she wants 12 eggs. If I said to you, please go get me a gross of apples, some of you may or may not know what a gross is, but a gross is 144 apples. Okay? If I say to you in chemistry, please get me a mole of something, I am talking about 6.02 times 10 to the 23rd. That's an enormous number. It's so big, in fact, that if you started counting right now, actually the second that you were born, and you counted one number every second for your entire life, you would not be able to count that high. Because what this really means is that I am going to have, after this decimal right here, I am going to have 23 numbers. So if I wrote 6.02 or 6.02 times 10 to the 23rd out in longhand, it would be 602, and I move the decimal 2 places to the right, and then I would have to put 21 more zeros after 9, 10, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. So if you started counting right now, you couldn't count that high. All right. What does this mean for us? Well, a mole is just an easier way of saying things. So if I tell you, go get me a mole of carbon, because the carbon atoms are so tiny, you can bring me those carbon atoms. But how do you know if you have a mole? We have to have an easier way of determining whether or not I have a mole of something. And we do that by mass. When you look at your periodic table, in the upper left-hand corner, there's an atomic mass. That atomic mass translates to the amount of grams that you would need to bring me 1 mole of that substance. So if I asked you for 1 mole of lithium, I am really asking for 6.9 grams of lithium. And I'm going to round to the nearest tenth, just like we do with everything. Okay, if I asked you to bring me a mole of carbon, you would be bringing me 12.0 grams. If I asked you to bring me a mole of, I don't know, let's pick something else here, oxygen, you would be bringing me 16 grams. Again, rounding to the nearest tenth. And so that's another 9 or an 8. I can't read that right now. If you round that up, this becomes 16. Okay? So what this does is it allows a chemist to measure accurately how much of something that you would be needing for an experiment. If I need 1 mole of something, then I know that I have to bring or measure out that many grams. So we need to be able to convert moles to grams and grams to moles. Alright, we are going to convert from grams to moles using a formula that's given to us on reference table T. Now if you, let's see, I can bring up the reference tables here just to show you where you can find it. Reference tables, come on, reference tables. They're coming. Here, second one down, mole calculations, and they give you the formula for converting between grams and moles and grams. In this short video, I'm going to only go from grams to moles, and we'll see how to go from moles to grams in the next video. Alright, let's get right to it. Let's say that I want to know how many grams, how many moles, there's my question word, let's get a pen, how many moles, how's my question word right there, are in 18.25 grams of sodium chloride. First thing I do is I write down my formula. Moles equals grams over gram formula mass. And if you don't believe me, come here, pen. Look right here. Remember, moles equals grams, which is the given mass, over gram formula mass. So I just wrote it grams, which is the given mass. That's what's given to you in the problem, divided by gram formula mass. Okay, so we were given in this problem 18.25 grams. That's my given mass. Okay, so now I have to calculate gram formula mass. And how do I calculate gram formula mass? Well, if you don't remember, go back to the program on calculating gram formula mass, but I'm going to do it for you. We've got sodium chloride here. Sodium chloride's formula is sodium and chlorine. Now, when you write the formula from the name, you must write your oxidation numbers in and cross them down. So this 1 comes down here. I'm not going to write it because we don't generally write 1 as subscripts. This 1 comes down here, and then I've got a 1-to-1 ratio. Because it's ionic, I have to keep it in lowest whole numbers. So lowest whole numbers, this is an empirical formula. Okay, so now we have to figure out the gram formula mass of sodium chloride. Of course the phone is going to ring now. Of course it is. We're just going to ignore that. Okay, let's take sodium. And there's 1 of them. And that sodium, we have to look up what it weighs. And when you look it up on your periodic table, it's in the alkali metals. So we're going to scroll all the way over here. And we're going to see 22.98. And we're going to have 23.0 grams per mole. That's a bad 3. Okay. And then we're going to do chlorine. There's 1 of them. You can look it up as well, but I know what it is, so it's 35.5 grams per mole. And then we're going to multiply that out. So we got 23.0, and then we've got 35.5, and then we're going to add those 2 up. So we've got 0.5, and then we've got 58.5 grams per mole. So that's my gram formula mass. That's what I calculated here. This number goes there. Okay? This number is going to go there. So we've got 18.25 divided by 58.5. Let's do it over here, just so that I have some room. So we're going to write moles. Don't be lazy. Write everything down. You got your grams, which is given, which is 18.25, with the units, grams, divided by 58.5 grams per mole. And then we're going to put it into our calculator. This number into your calculator first, divided by 58.5, and we're going to get 0.3 moles. Okay, and all my students know that I love my little clouds. There's my answer, 0.3 moles. Okay, now let's do one more, and this one is a little bit more challenging. I don't want that. I want to erase everything. This one's a little bit more challenging only because we have a more difficult formula to write. In this case, let's see, let's bring this up so it's higher on the page. There we go. Oh, too high. Come back, come back. Okay, here we go. How many moles are in 0.56 grams of aluminum sulfate? Alright. Let's say that I was taking an exam, and on the exam, I didn't know what kind of question I'd be asking for. But I read this question and it says, how many moles? First of all, there's my question word, so that I know that the question is coming right after that. How many moles? And when I'm looking for moles, I go to myself, self. Oh man, there's a formula on my reference tables. You have to know. Can I make this bigger? I think I can. You have to know how to read your reference tables. Okay? So here's a mole calculation formula. It's right there. I'm going to take it onto my paper and I'm going to write it down. Moles equals grams over gram formula mass. Okay, this is my given mass. On your reference tables it says given mass. This is given mass is in grams. So I'm going to come over here and for the sake of this video I'm going to put that given mass in a cloud, in a blue cloud. So that blue cloud there is 0.56 grams is going to be 0.56 grams. We still need to find gram formula mass. They didn't give it to us. We have to actually calculate it. That's why it's so important that you know how to do gram formula mass. And they didn't give us the formula. They gave us the name. So we have to take aluminum sulfate and we have to make it into a formula. Aluminum is a +3 oxidation number. Sulfate doesn't end in IDE, so I know that it's probably going to be on my table E. Again, knowing your reference tables is key here. So let's go up to table E, and let me show you where you can find that. Okay, sulfate is right here. It's a polyatomic ion, and it has a -2 charge. So let's get back to that page. So we've got SO4 with a -2 charge. Now we're not done. We have to cross our charges down, our oxidation numbers and charges down, and when we do that we're going to get a subscript here of 2 and a subscript here of 3. They cannot be reduced any further, so we're good to go there. And then I'm just going to rewrite it so that it looks nice and neat. Al2 parentheses SO4 3. Okay, so here's my formula. Does it need anything else? No, we're good to go. So we are going to now figure out what the gram formula mass is for this aluminum sulfate. We have an aluminum. There's 2 of them. We have to look up how much aluminum weighs, and it's 27.0 grams per mole. We have to look up sulfur. Well, actually, how many sulfurs do we have here? This 3 is for the entire SO4. So there's 3 S's. This SO4 means SO4, SO4, SO4. What it really means, if you don't understand this, it means there's 3 of these SO4s. SO4, SO4, SO4. Okay? And because there's 3 SO4s, there's 1, 2, 3 S's. Let's go back to blue. Okay, so we've got 3 sulfurs, and the sulfurs weigh 32.1 grams per mole. Okay, where am I getting that from? Where am I getting these numbers? Right here. Sulfur. 32.065. I rounded it to 32.1. Okay, and then finally we have oxygen. Oxygen, how many oxygens do we have here? Well, we've got 4, 4, 4. 4, 8, 12 oxygens. 12 oxygens. They have a mass of 16.0 grams per mole. And we're going to have to multiply all that stuff out. Okay. 2 times 27 is 54. 3 times 32.1 is 96.3. I'm just not writing over here because I'm afraid my pen will die, but I should put the units there. It's grams per mole, and then we have 192.0 grams per mole. Okay, we're going to add all these guys up. 0 plus 3 is 3. Do some math, blah, blah, blah. We get 342.3 grams per mole. Oh, pen, don't die on me now. Okay, so this number that we just calculated, this number right here, okay, that's this gram formula mass. And yes, you should write it out. Make sure you write everything down. Okay, so now we got 0.56. We're going to divide it by 342.3 grams per mole. And we're going to get a very, very small number. .0016 moles. Okay, moles can be written M-O-L-E-S, M-O-L-S. It cannot be written just as M because that would be meters. So we've got 0.0016 moles. Now if you really want to get fancy, if they ask you to write it in scientific notation, we could write this as 1.6 times 10 to the negative 3 moles. Okay, I didn't make a mistake here. This E is optional. You can write M-O-L-S or M-O-L-E-S. Okay, so this one is a little bit more complicated, but I think we did a pretty good job with it. Alright, this is what I want to see on your paper. I want to see all of this work. Okay, on to the next step.